Second, the balls and the balls must be in perfect contact. Last, a figure that is completely covered when turned or flipped is considered the same shape.
As you know, our goal is to generalize the number of polyominoes. So we started to think in terms of the sequence to draw a general term. But as you can see, the number of polyominoes are quite irregular, like 1, 1, 2, 5, 12, 35, 108, and so on. And also, we couldn't understand the part with holes and without holes in the table, with holes and without holes. So consequently, we gave up to approach the aspects of sequence. Yet, we came up with two suspectable ideas. Next presenter Kwon-hwa will explain the first idea.
We saw polyomino in terms of the number. Our method 1 is based on one idea. It is that finding a number of polyomino by placing squares is same with painting all the squares and color it. For example, please look at this picture. In this picture, the black side will be the polyomino. We want to say that we first drew all the squares earlier and then coloring it like this black part. The coloring part will be the polyomino. By that idea, we just have to color each floor. We used combination to get the number of polyominoes. At the first floor, color the number of squares that you want. And equation is that. And combination A1. And then at second floor, color the square like first floor. But to ensure the number of square that we use doesn't exceed the number of total squares. So we subtract the number of squares that then we use in first floor. So second floor is n subtract A1 combination A2. And then other floors proceed just previous floor. And then nth floor look like that. This equation use sigma, so we can consider every number of square in each floor. Then we can get the number of polyomino. But this method has a critical point. Please look at this picture. Like this picture, a shape that doesn't conform to the rule of polyomino also be included. This is a problem of the first method. Next, I'm going to present a method that solves the previous method error. First, we limited the total area and we approached it using the number of cases where a particular space was painted or not painted. Please attention to these pictures. Method has one premise. The premise is sum of the width and length of a limited space must equal the total number of squares. Based on this premise, set number of square on horizontal axis as p, set number of squares on entire square as n, and set general term multiply the number of squares on horizontal axis by p times and multiply the number of squares on vertical axis to induce a primary equation for n as shown in the picture above. If we were to count like this, we can't solve problem of not having a shape as the error of first method. But we couldn't exclude the number of overlapping cases when turning or flipping. Thank you for listening to our presentation. Do you have any question?